Okay, so in the last video, I demonstrated how to solve a quadratic equation that we were unable to factor using a technique called completing the square, and then taking square roots of both sides of the equation. So what I'd also said is that, when you first see that, it can be a really kind of like daunting looking process. And I said that I show you kind of slow it down and show you some techniques for doing that. So that's what we're going to do right now. We're going to show you, or I'm going to show you, how to complete the square before I actually have you go ahead and apply that to solving equations. So really, what we're going to focus on right now is how do we take an expression and turn that into a perfect square trinomial. So let's take a look here. Completing the square is what it says up on the top. So in words, to complete the square for the expression x squared plus bx, add the square of half the coefficient of the term bx. So if you look, and there was a typo in the notes, but that should be fixed by the time that you see this. All we're doing here is we are adding half of the middle term squared to make this a perfect square. All right. So let's go ahead and take a look at how this is done. I don't know why this screen keeps jumping around, but all right. So remember, when we factor perfect square trinomials, what we're actually building in our area diagram is a perfect square. Okay. So the dimensions on the left-hand side of the square and on the right-hand side of the square have to be identical. Okay. So the way that we're going to do this, x squared, we're going to divide that in half. So we're going to put an x on each side. And then 8x, we need to divide that coefficient in half. So now if we look, if we multiply this out as it stands, x times x is x squared, which gives us the first term over here. Then if we continue with our area diagram, 4 times x is 4x. X times 4 is also 4x. Now, if we add those two together, we get our middle term. Now, to make this a perfect square, we need this term c. And to find that, all we have to do is to multiply these two constant terms together, and we get 16. So we get x plus 4 times x plus 4 equals x squared plus 8x plus 16. So the value of c that we have to add to this right here is 16 to make it a perfect square trinomial. And it factors to x plus 4 all squared. Now, the kind of shortcut for doing this is just taking the middle term, which is 8, dividing that by 2, and you get 4, and then squaring it, and you get 16. But the area model is just kind of visual way of doing this, and I like to do it this way just because it's another, one less formula that you have to worry about. All right, let's try it on the next one. So again, we're trying to make a square. So those two dimensions have to be x and x. And now we're going to take the middle term, we're going to divide it by 2, so -6 and -6. And then we're just going to complete our area model by multiplying. X times x is x squared, -6x, -6x. If we add those together, we get -12x. And then this last box, which is going to be the c value that we have to add to make this a perfect square, is -6 times -6, which is 36. And again, that's the middle term, -12, divided by 2, -6, squared, 36. So we have to add 36 to make this a perfect square trinomial. So x squared minus 12x plus 36. So that's our value for c here. That makes it a perfect square trinomial. And that's going to factor to x minus 6 times x minus 6 which is x minus 6 all squared. Okay, the last one. Now, again, I'm not going to use the area model first. What I'm going to do is I'm going to use the rule first, and then I'm going to show you that it works using the area model and why it's kind of helpful to use the area model in a situation like this. So to make this a perfect square trinomial, this expression, a perfect trinomial, we need a number c that is b over 2 all squared. Okay? So b over 2 is 3 over 2 all squared, which is 9/4. So x squared plus 3x plus 9/4 is a perfect square trinomial, and it should factor to x plus the term that we squared originally, which is this right here, all squared. Now, again, if we go ahead and use the area model to do this, we're going to see that this is verified. So x by x to give us our first term, x squared. And now we're going to take 3 and divide it by 2. So 3 over 2 and 3 over 2. We get 3 over 2x, 3 over 2x. And if we add 3 over 2x plus 3 over 2x, we get 3x. 3 halves times 3 halves is 9/4. So if we look at the area diagram, these terms right here all added up give us this trinomial. These two binomials here are what we get on the right-hand side. So you're going to practice this technique, just taking a random expression and making it a perfect square trinomial. You're going to do that. And then in the next video, what we're going to do is we're going to see how to use this technique and taking square roots to help us solve quadratic equations that we were unable to or we're unable to factor. And actually, the cool thing about this technique, kind of as a sidebar, is it works for any trinomial. So even if the trinomial is factorable, this technique is still going to work. And you're going to see that in some of the examples that we do in the next video. All right. Like I said, I hope this was helpful. And we have one more video to go. See you in the next one.